Hi, in this video, we want to look at some functions that we have for working with geospatial geometries in R. Specifically, we're going to be taking a look at the SF package. So R has plenty of packages for working with geospatial data. SF is one of the more common ones, and it works well with other packages. Here, we're going to just dig into some more nuanced, more particular functions, more options that we have when we're in this package. All right, so first thing we're going to do is going to load our data. Our data is going to come from Pasco County. So in other videos, I use this data set. We're looking at the elementary schools. And so here's the website to get the data that I downloaded. And thank you so much, Pasco County Public Schools. All right, so I'm going to go ahead and load two data sets. When I wrote the code, I was planning on using both. I'm almost only going to use the school zones in this. So I have the location of elementary schools, which I'll refer to as points, and then the school zones for the elementary schools, which I'll call polygons in this. So here is the points data set, SF points. So here I like to always name my objects by their class, then a description. So SF, class is SF, and then points. So I know what I'm looking at. Here's my file path. Scroll down a little bit. And here's our information about it. And now I'm going to go ahead and get the polygons data set, which is the one that we're going to be using almost exclusively in here. And you'll notice I'm using the SF package, stread, just to read in the shape file. All right, and we can see that it says 48 features in 3 fields. So here we have a data frame connected to our polygons, and each row of the data connects to a polygon. Okay, and so we can see that here's our bounding box. So we know in terms of X and Y coordinates, what's the minimum, maximum. You know, these numbers don't look like latitude and longitude, now do they? Well, this is the North American datum 83, centered on West Florida. And so this is not the standard longitude and latitude coordinate reference system, but it's good enough for our purpose. If I wanted to work with other data sets to incorporate things, this probably would not be the best choice unless it happened to be on NAD 83 also. All right, so first and foremost, let's just go ahead and plot just so you can see what it is I'm talking about as I'm working through. So SF polygons, if I just plot it, default plotting, slap it down, for each column of data I have in the data set, it's going to plot the polygon and it's going to color in it corresponding to the data frame. So here it's used school names to come up with a coloring system and colored accordingly. Use the abbreviation for the schools and colored accordingly. And then cost center, which is the school's ID number within the district, which is a character string. It went ahead and colored also. Okay, so now what we're going to do, we're going to go through several different functions that we have in the SF package, and we're going to see how does it change the geometry so I can know what the utility of each function is. All right, so first and foremost, let's look at the class I'm working with. So here's my SF polygons. Its class is actually 2, SF and data frame. Okay, so how R operates, and it doesn't work out 100%. This is 100% correct because I have plenty of times that this didn't work out for me. It actually didn't work out for me today at work. What it will do, if I call a function on an object, it's going to see, does it have a way to handle the first type in the class? If it does, it grabs it, it uses it, and it's done. If it doesn't, it goes to the next class in the vector. And if it doesn't have a way to handle the first two, then it goes to the third, fourth, and so on, until either it catches something that it can work with or it gives you an error. Okay, so now let's go ahead and let's get the geometry, just the geometry of our object. So I'm going to use the stGeometry function. I'm going to say, hey, the object is my polygon spatial data set. And now the class is going to be SFC polygon. And you notice I have SFC polygon, polygons. So I'm naming the class and then description of what it is. And we can see that now the class has changed in both slots. Now let's take a look at what we've got. All right, we have a geometry set for 48 features, polygon. All right, same bounding box, same projection, but hey, you'll notice that our data frame is gone. So by getting the geometry, just the geometry, what I basically did was I said, hey, I want the geometry, get rid of the data. And so now let's go ahead and plot that. Now you'll notice that when I do that, I no longer have 3 columns of data. So it only plotted one time and it didn't color it in because it doesn't have data to use to color in the polygons. So there, we can see what, each school zone looks like. One thing we can also do, we can set the geometry. All right, so when we set the geometry, what we do, we specify what type of geometry we want. And the default value is null. If I say null, that's equivalent to just to give me the data frame, drop the geometry. Another option is to specify an object that I want to convert the class to. So what I could do if I had an object, I could put the object here or the class of the object here, and then the SF package will try to convert the geometry to that format. And so when I do that, we'll notice that it converted the polygons, SF polygons data set, to something without, or to the same geometry format. So now here are all these polygons. And if you'll notice, if I scroll back up, those polygons were not listed before because they weren't part of it. I invoked that by saying, hey, convert it to the SFC polygons format. Now, another option I have is to drop the geometry. So that's saying, hey, I want the data frame. And you'll notice I get the data frame back when I drop the geometry. Another thing I can do is I can convert the geometries. Now, depending on the geometries of your object and the geometry you convert to, this may or may not work. Here is from the help documentation, all of the types of geometry that you can convert to. Okay, so what I'm going to do, just to demonstrate this, I'm going to convert my SF polygons, which is polygons, into each of these types of geometries, and then we're going to take a look at what happens. Okay, so to do this, I'm going to store what I've got into a list. So what I'm going to try to do, I'm going to try to cast the geometry of this object into these types of geometries. And I'm going to store it into a list, which I'm going to call list underscore cast, because it's the output of casting the geometry to another. Okay, and so now some things are going to work. A lot of them are not. So what I'm going to do, I'm going to use a try function so that as I iterate through this, if I get an error, it just skips to the next one. It doesn't slow down my process. And you'll notice I get plenty of errors, and we get warnings repeating attributes for all subgeometries for which they may not be constant. Plenty of errors, plenty of, it doesn't know what to do, but it's gonna make something happen. So now let's take a look at which ones worked. All right, well, we can see that the ones that worked were multi-polygon, multi-line string, multi-point polygon, line string point, and multi-curve. Now, before I made this video, I plotted all of these, and multi-curve would not work for me, so I just omitted from the upcoming code. But now let's take a look at what happens. So let's take a good hard look of what we had previously. Here is school name. So keep this kind of in your mind for what does this look like? Where do I have green? Where do I have gray, purple, so on? Just kind of keep an impression, an idea of where it is. All right, so now when I convert to multi-polygon, that looks about the same. Not a whole lot changed. Okay, let's see what happens. Let's go to multi-line string. Oh, hey, look at that. So it took the data and it colored the boundary instead of the polygon itself. All right. Kind of unexpected. Didn't think that would happen, but whatever, it's all good. All right, now let's look at multi-points. So what it did, it took the boundary points, it applied those as points and just assumed that they're not lines. All right, well, that might be useful for the application I'm working on if I want to, plot down the individual points of the boundary. Polygon, nothing changed. Line string, it took the boundary and just made a line. All right, I'm okay with that. I'm feeling good. Points, I took the polygon points and just plotted them, assuming that there is no line connecting them, but did color them by the column. And multi-curve would not, this code right here would not plot. So even though I was able to cast the geometry, the plotting didn't work, so I omitted it here. It might work for a different type of geometry set that you've got to work with. Now, let's do some operations on the geometry. So now I'm going to go back to how I had it before of working with my SF polygons. And now I'm going to just use some other functions just to get a feel for what these functions do if I need these down the road while working on a project. First and foremost, let's compute a buffer around each of our polygons. So now what is happening here is that for each school zone, it's kind of stretched out the boundaries to make it so that we have a little bit smoother of boundaries. Now, something about this is now we have overlap. Previously, in our school zones, you were either in school zone A or you were in school zone B. What this has done is that now there's overlap. So this is no longer properly partitioning the county, and so what's going on is that it's taking it and it's overlapping these new boundaries on top of each other as it plots. So when I look here, so like this gray was plotted before this green because we can see that the green is overlapping on top of the gray. And so this is something to be mindful of if we choose to use this function. Now we can also just get the boundary of a polygon. So here, I just want the boundary. I don't want the polygon itself. Next thing I can go for is get a convex hole. So a convex hole is if I take a straight line between any 2 points of the polygon, that line will be completely, totally, and utterly inside the hole. So think about like a crescent moon. If I have a crescent moon or maybe a U shape, at the tips, I draw a line. That line is not inside the crescent moon shape. That is a non-convex shape. What I want to have, if every line I draw is completely contained, if every line I draw between 2 points on the polygon is completely inside the shape, then it is a convex shape. So what this does is make sure that I have a direct line between all 2 points on the polygon without exiting at any time. Now, when I plot this, there's going to be overlap. So I know, like for the purple, what is displayed is not convex because here, the line from here to here goes through the green. Okay, well, really what's going on is that this purple was plotted before the green and the green was put on top of it. So I do have a convex hole for the purple, but because of the stacking, I can't completely see it. If I plot a subset of the polygons, I'll be able to see it. Now, simplify, what it tries to do is go through and pick out points on the boundary that is not useful, that we can do without. And if we were to like zoom in and really scrutinize, we'd be able to find them. This is good if I want to reduce the number of points for my plotting. Maybe do some data reduction without a lot of information loss. Triangulate the points. So here, this goes through and this tries to make every portion of the region into a triangle. And this has purposes in terms of like finite element methods and mathematical optimization, stuff like that. We can create Baroni tessellations. Kind of looks interesting. We can compute the centroid of the geometry. So now remember, a centroid of a geometry is like the average of the coordinates. So the average of the longitude, average the latitude. This may not be actually in the shape itself. That the point may be outside. Like imagine like a crescent moon shape. That if I take the average of the points, it's possible to have a centroid outside the shape itself, or if I have islands. So here, the centroid may or may not be within the shape I want. Next, this one, this is going to perform very similar if I have a convex hull. But what it's going to do if I have something that's non-convex, it's going to make sure that the point is inside my polygon. That way, when I plot a point down, it's guaranteed to be inside the geometric shape, which can be very good for labeling. Now, this last one, what it does, it goes through and it reverses the order of plotting. So it plots the same shape, but instead of going, clockwise or counterclockwise, it goes the opposite direction. All right, well, that's all I've got for you. Take care and goodbye.